today we're going to look at the opposite of direct proportion, which is inverse or indirect proportion. So the words that are used to demonstrate this is either indirect proportion or inverse proportion. Both mean the same thing. So basically, indirect or inverse proportion is when if you're comparing two variables, as one variable increases, the other one decreases. So that's the important bit. As one variable increases, the other one decreases. So it's going in opposite directions, if you may say. If you think back to when we looked at direct proportion, when one variable increased, the other one increased at the same time. Both the variables might have increased with different increments or different factors, but it still increased. Whereas in indirect proportion, it's the opposite. So for example, if a man needs 12 hours to mow all the grass, then 2 men will need 6 hours because there's 2 people now, so it'll take half the time. If there's 3 people, how many hours will it take? How many hours will it take if it's 3 people? Yeah, that's right. So it will take 4 hours because it's 12 divided by 3. If there's 6 men, they will take 2 hours. So 12 divided by 6. If we show this in a table, so the number of men who mow the lawn is 1, 2, 3, or 4. So 1 man will take 12 hours, 2 will take 6 hours, 3 will take 4 hours, 4 will take 3 hours, 6 will take 2 hours. Now what do you notice? Think back to when we did direct proportion and we did a table like this. Think back, we got a constant value. How do we get that constant value? We got that by dividing the y by x. So if we did 12 divided by 1 or 6 divided by 2, that was in direct proportion. But over here, it's similar, but still a different operation. What do you notice about the 2? So if you have a look at the 2. 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2. Yeah, so these two, they multiply to give 12. 2 times 6 is equal to 12. 3 times 4 is equal to 12. 4 times 3 is equal to 12. 6 times 2 is equal to 12. So in an indirect proportion, the values x and y will always multiply to give the same answer. Again, that same rate is known as the constant of proportionality, given by k. Okay, now when we have two values that are proportional to each other, so if we want to say that x is proportional to y, we use this sign. That sign stands for is proportional to. Is proportional to. Okay, and as we looked in the example that we did in class the other day, when we looked at the amount of time, what did we look at? The number of lollies that we bought. Okay, so if one Tupperware bottle costs $20, then 2 Tupperware bottles will cost $40 and so forth. And when we find the gradient of that function, it gives us the constant of proportionality. Okay, so we figured that the constant of proportionality gives us the gradient of the graph. So direct proportion has to do with linear functions. And therefore, if we want to include that in the constant, if we want to write that as an equation, then it becomes x equals k times y, because the k over here is the constant of proportionality. In the inverse proportional, in the inverse function, it actually is the opposite. So x is inversely proportional to y, which is written like that. If you think back to when we did index laws, inverse is basically the reciprocal. So inverse of y is the reciprocal of y. And if we write that using our proportionality constant, then that becomes k over y. Okay, sorry, if we write that as an equation. Okay, now the graph of when we have direct proportion, the graph that we get is a straight line. In comparison to that, when we have inverse proportion, the graph that we get will make a curved line. Okay, which means that it looks something like that. So it's what it tells us, if this is x and if this is y, this is as x increases, so as we go from 1, 2, 3, 4, so forth, right up to whatever value that is, then the y values are decreasing. So as we go from left to right on our x values, the y values are actually decreasing, coming from top to bottom. So if we write that, we can say as x increases, y decreases. And when that happens, then we know that it's an inverse proportion. Okay, now take note that it's possible for both direct and inverse proportion that the function can be a square, a cube, a square root, etc. And we'll look at some examples to identify this. Just for now, let's look at an example for an inverse proportional. Okay, so let's look at the first example. It takes 4 people 3 hours to paint a fence. So if I write that down, that time is equal to 3 hours, and people, say P, is equal to 4. So 4 people. So when time is 3, so if I plot this on a table, that's time. I'm going to leave it as 1, 2, 3, and then I'll go to maybe 6 and 10. Okay, so for 3 hours, it takes 4 people. So what would be our constant of proportionality? Remember, when we look back, how do we find the constant of proportionality? Over there, this is our constant of proportionality. How do you find that? What do we need to do? The values x and y always multiply to give the same answer, and this same answer is called the constant of proportionality. So going back to our example, what is our constant of proportionality? K would always be equal to x times y. For this example, it's t times p. For the information that we're given, it's 3 times 4, and that is equal to 12. So what that means is that if you multiply 3 and 4, it should give you 12. So 2 times what gives us 12? 2 times 6 gives us 12. 1 times what gives us 12? 1 times 12. 6 times what gives us 12? 6 times 2. 10 times what gives us 12? 1.2. Okay, so let's look at the questions. How long will it take 2 people to paint the same fence? So 2 people, how long will it take? 6 hours. Now to show that, what you can do is, because we know that our x is equal to k, so I'll just rewrite from here. So let's go from there. So let's start from there. So k is equal to x times y, or that is equal to t times p. That's k. So to find, it says how long, so that means we need to find the t. So therefore, if k is always going to be 12. It's a constant. So 12 is equal to t times, for 2 people, 2. So therefore, t is equal to, what do you do to isolate t? You divide by 2 on both sides. So therefore, we get t is equal to 12 divided by 2, which is equal to 6 times 6 hours. And if you look, that's what you get. So yes, you can do the table, but you have to know how to show this working as well. Okay, the next question. How long will it take 6 people? Again, from the table, we can say 2, but to show the working, same deal again. K is equal to t times p. 12 is equal to t times 6. To find t, we divide by 6 on both sides. So therefore, t is equal to 12 over 6. And that's the other way around. T is equal to 2 hours. So that's how you would show. So what you need to by now identify that if it is, okay, so just as a summary, for direct proportion, y is equal to k times x. For indirect proportion, k is equal to xy. Make sense? Or if we want to write it the same way as the top one, then y will be equal to k over x. So that's the difference between the two. This is direct and this is inverse. And that is something that we need to remember. Okay, we'll look at some examples in class about how we can use direct and inverse proportion with square functions or cubic functions. So what I need you to do is make some notes about this video and come prepared in class to do some examples. Thank you.